Hey guys, today again we continue our study in probability. We're going to look at what's called theoretical probability versus experimental probability. Now, in theory, we can state the chance of something happening. But when you actually start doing the experiment, your outcome might be a little bit different. So let's go back to something we know. Let's go back to the rolling of a dice. Now, if you we talked already, we've already rolled this dice a few times, but we know that if I say, what are the chances of me rolling a 6, or let me pick a different number. The chances of me rolling a 5, we know that there's 1 out of 6 chances that I'll roll a 5 because there's 6 sides on the dice. One side has a 5 on it. So if I roll that dice, the chance of me getting a 5 is 1 out of 6. Okay? Now, if I roll the dice, this is what this means. This means that if I roll the dice 6 times, theoretically, I should only get 5 one time. But maybe I get 5 every single time. Now that'd be crazy, right? Like the chances of that happening is seemingly impossible, but it is possible. It's not very likely, but it is possible. Or I could never get 5. In fact, if we were all sitting together in a classroom right now, we'd all be rolling dice 6 times to see if that would happen. Now, if you have a pair of dice, you can try, or one dice, you can try this, but I have this dice in front. And so let's see, we're going to roll it 6 times. And in theory, theoretically, I should only get 5 one time. So let's see, we're going to have to help me counting this out. All right. In fact, if you want, you can if you want to have some more fun with this, you can go ahead and have a number in your head, something between 0 and 6, and say, I think Mrs. Vitella is going to get 5 on her dice twice, or I think she's going to get it all 6 times, or I think she's never going to get it. Why don't you go ahead and pick a number in your head? Either 0, 1, 2, 3, 4, 5, 6. You got the number? All right, here we go. We're going to roll this dice 6 times. So, okay. Rolling, rolling, rolling. Stop. Okay, I got a 6. I need a 5, so that's 1. Got a 1. That's the second time I rolled it. Third time I rolled it, I still haven't gotten a 5. This isn't looking good for me. Oh, I got a 1 again. That's the fourth roll. Not looking good for me. I got a 1 again. Oh my gosh. I might not get a 5. Okay. If you said 0, you might be the winner on this one. So let's see what happens. One more time. Ah! I never got 5. So out of 6 rolls, I should have gotten 5 one time because the probability of me getting it would be 1 out of 6. But as you can see, I didn't work out for me. Do you want to do it again? Because I feel like I want to try that again. All right, let's pick the number 4. All right, 4. Okay, think about it. I want you to think Mrs. Vitella's going to roll a 4. Now, last time if you said 0, you're the winner because I didn't get it at all. In theory, I should get it one time. Let's see how many times I get it this time. Okay, think of a number between 0 and 6. How many times do you think I'm going to roll 4? Okay, ready? Do you have your number? Don't cheat. Ah! I got it on the first time. So I got it once. Let's try again. Didn't get it that time. That's 2 rolls. Didn't get it on that one. Wait a minute. Okay, didn't get it on that one. That's 4 times. I've gotten it once. Didn't get it on that one. Okay, I got one more time. I've rolled it 5 times. I've gotten it once. Let's see if I get it again. That time I got exactly 1 out of 6. So if you said Mrs. Vattel is going to get it 1 out of 6 times, then you're the winner, because that's how many times. Theoretically, I should have gotten it once. And that time my experiment and in theory both matched up. But the first time it didn't match up. So you can see, like, sadly, most of the time it's not going to match up. And so that's again why people play the lottery, because when your chances of winning is 1 out of 2 million and you go ahead and play it, chances are you're not going to win, but somebody's going to win, right? So, all right, let's look at our notes now. Let's look at our notes. So we have experimental versus theoretical. And so we're going to write here theoretical probability. Okay, so this is vocabulary, is what should happen. For example, what is the theoretical probability of rolling 1 on a dice? And we've already stated 1 out of 6. What is the likeliness? Not likely, not likely. Okay, experimental probability. We've already tried this out. Is what actually happens. So, for example, we can roll a die. For example, I'm right here. We can roll a die 10 times and roll 1 5 times. What is experimental probability? Experimental probability in this situation would have been I actually rolled it 5 times out of the 10. Theoretically, when I roll a dice 10 times, I shouldn't get it more than once or twice. But in this situation, I got it 5 out of 10 times. Did we get the result we were expecting? And the answer is no, we didn't. I'm going to just go ahead and say we beat the theory. Theoretically, we should have only gotten it once or twice, and so we got it 5 times. So let's look at this right here. Then we're going to look at different scenarios, okay? So the first one says, what's the theoretical probability of spinning purple? So if I look at this, all the wedges are the same size. One is purple. There's 5 wedges. So in theory, I should get purple 1 out of 5 times. Now I could spin the spinner and maybe never get it. Or I could spin the spinner and get it every single time. But in theory, only once. Lisa spins the spinner 50 times and lands on the purple 10 times. What is her experimental probability? So if the total is 50 times and she lands on it, the purple, 10 times, she has her experiment, and in theory, they are the same. Okay, doesn't always happen, but it can happen. You feel like it should happen the same every time, but that's actually not true. Let's look at the next one. There are 10 marbles in a bag, so there's a total of 10 marbles. There are 5 blue, 3 yellow, 2 red. What is the in theory, what's the probability of picking a blue one? Well, let's see. There are 5 blue. So in theory, if I simplify this, in theory, I should pick a blue 1 out of every 2 picks. But again, I could pick them all and not pick blue to the very end, or I could pick all blue at the beginning. But in theory, I should only pick them half the time. Let's look at the next one. Next one says that I'm going to be drawing 20 marbles, and they give you a list. Now, I'm going to tell you sometimes they're not going to give you the word 20. Sometimes you're going to have to add them all up and see that and figure that out yourself, but they gave us a total, which was very nice of them. Okay. So, and then it says, what's the probability of getting blue? So, because we know that there's 8 blue, we have to assume that there's 8 blue in the bag. So we have blue and we have the total, and we would simplify that. Let's see, 4 goes into both of those. So that's 2 over 5 times. So based on her experiment, what's the probability of getting blue? Based on her experiment, what's the probability of getting blue is 2 over 5 times. All right. Now compare. Now I'm going to go ahead and cross this out because number 4 and number 5 are 2 different situations, so I can't really compare. So we can say this: experimental is not always the same as theoretical. Okay. Something to remember. Something to remember. All right. So, 2 vocabulary: experimental, theoretical. Theoretical is what in theory should happen. Experimental can change every time depending on how your experiment goes. All right. See you later. Bye bye.